Okay, so let me start it from the beginning again. Find the Laplace transform of f of t is equal to e raised power n, where n can take the values 0, 1, 2, 3, so on. Now, so this is f of t, and you know that the Laplace transform of this t raised power n will now be equal, as from the definition, 0 to infinity e raised power minus st t raised power n into dt. Then what I did, I say that let's put this st is equal to x, or this t will be equal to x by s. Then taking the derivative with respect to t, so implies this dt will be equal to this and so dt will be equal to this dx by s, right? Now substituting all these things in this integral, so this integral will now become integral 0 to infinity e raised to power minus x. Now t, instead of t I have x by s raised to power n into dt, we have dx divided by s. Taking this s out of this integration, so it will be 1 divided by s raised to power this n plus 1 integral 0 to infinity e raised to power minus x raised to power n into dx, right? Fine. Now, as I was saying, we have a gamma function. Since we know that the gamma function, since gamma of n plus 1 is always equal to 0 to infinity, this e raised power minus x into x raised power n into dx. And this gamma of n plus 1 is always equal to n factorial. So this whole integral is equal to gamma n plus 1, but gamma n plus 1 is in turn equal to n factorial. So this integral, so this whole integral will be the n factorial. Implies the Laplace transform of this function t raised to power n will be equal to this n factorial divided by s raised to power n plus 1. This is very important, and we are going to use it in a variety of the problems, right? Okay. Now, I'm not going to write down the Laplace transform. I'm not going to obtain the Laplace, but you can do it yourself. I'm simply going to directly write down the what could be the Laplace transform of some of the functions. Then you can, out of your own interest, you can do it. You can solve them yourself. But before writing all those this Laplace or those functions, one more thing is there. One simple thing: find the f of if f of t is cos square t, we have to find out the Laplace transform of a function f of t, right? Now, you know that since cos square t, cos of 2t is always equal to twice cos square t minus 1, right? Or you can say that this cos square t will be equal to 1 plus cos of 2t divided by 2, right? Then the Laplace transform of this, I can write down this. So the Laplace transform of cos square of t will be equal to the Laplace transform of 1 plus cos of 2t divided by 2, right? Or you can say that this is 1 by 2 into the Laplace transform of 1 plus 1 by 2 into the Laplace transform of cos of 2t alpha t. But हमने अभी इसको find किया है. What is this equal to? Now you know that Laplace transform 1 is equal to 1 by s. So it will be simply 1 by, or I can write down this as 1 by 2. दोनों का common ले लूँ. What is Laplace transform of 1? That is 1 by s plus Laplace transform cos of t. What is that equal to? Laplace transform of cos of at. अभी हमने इसको find किया है. Cos of at. What is that equal to? That is s divided by s square plus a square. But a we have the 2. So applying that, so this Laplace transform cos of 2t, that is equal to s divided by s square plus a is 2 square, right? Just further simplifying, you can keep it as such, s square plus 4. So instead of 2, I will write down this as 4. So this is the Laplace transform of cos square of 2t. Similarly, you can find out the Laplace transform of sin square t and some other things. Now let me write down the Laplace transform of some of the functions. You can just make a table of it, so that you will remember it. because we are going to use the Laplace transform while we will be solving this ordinary differential equation initial value problems. So the first one is we have find out the Laplace transform of 1. What is that equal to? 1 by s. The second is the Laplace transform of t raised power n भी हमने find किया है. So that is equal to n factorial divided by s raised power n plus 1, right? Where n can take the values 0, 1, 2, 3, so on. And the third one is the Laplace transform of e raised power at. What is that equal to? That is equal to 1 divided by s minus a, right? Similarly, we find out the Laplace transform of sine of at, or let me write now omega t. So what is that equal to sine of omega t? It is always equal to omega divided by s square plus omega square. The another one is Laplace transform of cos of omega t, cos of at जिसको हम बोल रहे हैं, that is s divided by s square plus omega square, right? The difference here, we are taking it omega divided by, here we are taking it s divided by s square. Then again we find out the another one, that is Laplace transform of cos hyperbolic omega t. At मैंने यहाँ पे लिया था, अब मैं यहाँ पे omega लिख रहा हूँ. That is not a difference. So it is always given by s divided by s square minus omega square. The other one is the Laplace transform of sin hyperbolic omega t. So this is always equal to omega divided by s square minus omega square. आपको ये याद रखने हैं, ठीक है? Because you are not going to solve this again and again, but we have find out all these things, all these so far. Okay. Then I was saying the inverse Laplace transform is also the true. So the what is, we are going to find out the inverse Laplace transform, but for the time being, just remember here the inverse Laplace transform. So this is the Laplace transform here corresponding to all these things. The inverse Laplace transform of 1 by s is always equal to 1, and inverse Laplace transform of this n factorial divided by s raised to power n plus 1. What could be that equal to? That is t raised to power n. And the inverse Laplace transform of this 1 divided by s minus a, that is equal to e raised to power at. Inverse Laplace transform of omega divided by s square plus omega square, that is equal to sine of omega t. And the inverse Laplace transform of s divided by s square plus omega square, that is equal to cos of omega t, and so on. Similarly for these two things, the inverse Laplace transform. Right? We will find out the inverse Laplace transform also. This is one thing. साइन हमने लिखा है, cos भी हमने किया है. Okay, few more are there. Let me write it here. You can derive all these Laplace transforms from the things we have already done. You can do it, solve it in few steps by yourself also. Now the Laplace transform of another one, the Laplace transform of अगर हमारे पास exponential है e to power at sin of omega t है, what is this equal to? It is always equal to s minus a divided by s minus a square plus omega square. Just s minus a इसको मैं ले रहा हूँ, e raised, because ये आपका e raised power जब आप Laplace transform e raised power a minus s, so वो minus term जो है यहाँ पे वो that will become plus. You can solve it yourself. Similarly for here s greater than a. Similarly, the Laplace transform of e raised to power at cos of omega t. What is that equal to? It should be equal to omega divided by s minus a square plus omega square, right? Now, if I have the you just solve these, मैं directly लिख रहा हूँ, लेकिन आप इसको find करिएगा. Just multiply it by e raised to power minus st. And then find out the integral. Now Laplace transform of e raised to power at t raised to power n. What is that equal to? It will be equal to n factorial divided by s minus a raised to power n plus 1. Right? Similarly, I have the Laplace transform of e raised to power at cos hyperbolic dt, yeah, omega t. So that is always equal to s minus a divided by s minus a square minus b square. Hmm? Similarly, Laplace transform of e raised to power at sine hyperbolic dt, that is equal to b divided by s minus a square plus b square. एंड साइन का हमने e to power 80 साइन कोसाइन का हमने लिखा था. Okay, fine. So these are some more Laplace transform. You just find out these, huh? Find out, just check whether यही मतलब यही आ रहा है कि कुछ और आ रहा है. Okay, fine. Now let me just tell you some of the inverse Laplace transforms और उसके बाद फिर आप in the inverse Laplace transform. Okay, some few things about this Laplace, this inverse Laplace transform. This is all about the Laplace transform. Let me tell you something about the inverse Laplace transforms. Fine. I hope आवाज मेरी clear आ रही हो. आ रही है? आवाज आ रही है मेरी?
नो सर,
नो सर,
ब्रेक हो रही है?
जी सर.
Okay. Now अब मैं पूरा लिखूंगा इस पे बोर्ड पे, आप उस पे भी ध्यान रखो. Now see, inverse Laplace transform में मैंने already ये चीज बताई थी. Now I say that if the Laplace transform of this function f of t is f of s, right? Then we call this f of t as the inverse Laplace transform of f of s. So कैसे हम इसको एक्सप्रेस करेंगे? That means inverse Laplace transform of f of s is equal to f of t, right? Now for example, हमने देखा था कि Laplace transform of t is equal to 1 by s square. ये शायद हमने नहीं किया है, but you can do it. 1 का हमने किया था s square, it's 1 by s square. So the inverse Laplace transform of 1 by s square किसके बराबर होगा? It will be equal to t. उल्टा. Now there is one important thing about this inverse Laplace transform कि जब भी Laplace transform exist करेगा, it will be unique. Whenever the Laplace transform exists, it is unique. However, the same is not true for the inverse Laplace transform. जब मतलब Laplace transform जब भी किसी function का exist करेगा, it will be unique. But the same is not true for the inverse Laplace transform. That means that it will not be a unique. It will have some different values. Also, this inverse Laplace transform operator. This is inverse. This is L. Inverse Laplace transform operator is also a linear operator. Is a linear operator. Linear operator. What does it mean? That means the inverse Laplace operator acting on the functions like I have a1 f1 of s plus a2 f2 of s. It is always equal to a1 f1 of t plus a2 f2 of t. So that is what I mean by the linear operator. Now let us do some simple exercise on this, the inverse Laplace transforms. Fine. Find the inverse Laplace transform of inverse Laplace transform of the following. For example, the first case I'm taking e raised to power minus 3s divided by s plus 2. Now, before going to this thing, I will tell you one thing about the inverse Laplace transform. One thing, remember that the inverse Laplace transform of some function f s minus a, it is always given by e raised to power at f of t. यानी फॉर एग्जाम्पल द अगर मैं इसका लैपलास ट्रांसफॉर्म यहाँ पे करूंगा इट विल बी इक्वल टू s माइनस ए. सो द e raised f of this f of s minus a is always given by e raised power at f of t, and the inverse Laplace transform of अगर मैं e raised power माइनस ए एस से इसको मल्टीप्लाई करूं f of s माइनस a, इसका जो इनवर्स लैप्लास ट्रांसफॉर्म होगा दैट इज ऑलवेज गिवन बाय f of t माइनस a then u a of t, यानी द वैल्यू ऑफ द फंक्शन विच विल टेक इट एट a. अभी मैं इस एग्जांपल से वो आपको समझ आ जाएगा what I mean by this u a of t. Now see, I have this particular function and I have to find out the inverse Laplace transform. Now since we know that, I will write down this again. Since inverse Laplace transform of e raised power minus as f of s minus a is given by f of t minus a u a of t. Now comparing the given function, this particular function with this particular function with this thing, f of s minus a यहाँ पे क्या है f1 divided by s plus 2. So comparing with this particular function, so we have comparing, let me write it, comparing this with this value, this e raised power minus 3s divided by s plus 2. We have what we have? We have what is a here, by the way? E to power as, e to power as. A is here 3, 3s. अगर ये 2s होता तो a is 2, अगर ये 5s होगा तो a is 5. And f of s किसके बराबर है? f of s, if I am comparing there, it is 1 divided by s plus 2. 1 divided by s plus 2. And what is f of t? f of t किसके बराबर है? It is e to power f of t. Okay, forget about f of t फिलहाल. Okay, then what is this? What is the Laplace transform of this integral? So that you will say that the inverse Laplace transform of this particular function, that means e to power minus 3s divided by s plus 2. 1 2 s plus 2. What will be it equal to? It is f of t minus a. Just a 1 minute. Okay. Fine. See, there is one more thing before going to this. Agar, what is the Laplace transform of 1 divided by s minus 2? 1 second. यहाँ पे मैं इसको साइड में लिख रहा हूँ. Then I will use the f of t as this. What is the Laplace transform? See, we have find out the Laplace transform of e to power 2t. किसके बराबर होगा वो? That is 1 divided by s minus a. A is 2, so that is 1 divided by s minus 2, right? So what is the Laplace transform of e raised power minus 2t? It will be 1 divided by s minus minus 2, that is s plus 2, right? Is it okay? So what will be the inverse Laplace transform of 1 divided by s plus 2? It will be equal to e raised power minus 2t. So inverse Laplace transform of this f of s 1 divided by s plus 2. So from that case, this f of t will be equal to e raised power minus 2t. यहाँ चीज ये आपको साइड में करना है समझने के लिए, लेकिन एफ ऑफ टी जो यहाँ पे होगा, इट सिंस एफ ऑफ एस इज इक्वल टू दिस, सो एफ ऑफ टी विल बी इक्वल टू e raised power minus 2t. Okay, then the Laplace transform e raised power minus 3s divided by s plus 2 will be equal to this thing, t f of t minus a. What is f of t? F of t is, so f of t is e to power 2t, so it will be e raised power minus 2 t minus f of t 2 into t क्या है, t minus a है ना, ये t minus a क्या है, a is your 3, so this is e to power minus 2 t minus 3, then u3 of t, u3 because a of t. मुझे पता है आपको ये समझ में नहीं आया होगा, just hold it for a while, I will come to this again. मुझे असल में ये वाला एग्जांपल थोड़ा इसके बाद लेना था. सी इस एग्जांपल से आपको और समझिए, थोड़ा सा सिंपल वन है. आई हैव टू फाइंड आउट द इनवर्स लैप्लास ट्रांसफॉर्म ऑफ e raised power minus 2s डिवाइड बाय s स्क्वायर. ठीक है, ये मुझे फाइंड करना है. बट मैंने अभी आपसे कहा था f लैप्लास ट्रांसफॉर्म ऑफ, इनवर्स लैप्लास ट्रांसफॉर्म ऑफ दिस f of s minus a is equal to e raised power at f of t. एक तो ये है, I'm not going to use it, and the another one is inverse Laplace transform of शाबाश, जो मैंने अभी लिखा था inverse Laplace transform of e raised power minus as f of s is equal to f of s. हम यहाँ पे देखते हैं ना, so inverse Laplace transform e raised power minus f of s, it is always given by t minus a, f of t minus a into u a of t. अब यहाँ पे इसको जरा मैं स्टेप बाय स्टेप समझाऊंगा आपको. So we have to use this property to find out the inverse Laplace transform. So f of e raised power minus as f of, so here e raised power minus as f of s. If I will compare this with this, what is my a? What is a here? So from these two, e raised power minus as f of s is equal to, for example, e raised power minus 2s s square. So from these two, here a is, this is minus, a is equal to 2, and what is f of s? F of s is equal to 1 by s square, 1 by s square. मतलब, so we need to find out, so we can find out the Laplace inverse Laplace transform of f of this fs किसका है? So that is equal to t. So we know that. अभी हमने किया था Laplace transform of t is equal to 1 by s square, right? So the inverse Laplace transform of 1 by s square किसके बराबर होगा? F of, that is simply t. So what will be the f of t here? So f of t will be equal to t, isn't it? F of t will be equal to t. So what will be the inverse Laplace transform of this integral? So that you can say that the inverse Laplace transform of this integral, that is e raised power minus 2s divided by s square, will be equal to this thing, f of t minus a. But f of t क्या है? F of t is t minus a, so it will be t minus 2, t minus 2 u of that, which is a function that taking the value at 2, u a of t, that is u of u2 of t. So this is the inverse Laplace transform. Is it okay or still not? Now you just move to the previous problem. Okay, fine. One more example about this thing, कैसे हम इसको find करते हैं. Now find out the Laplace transform of, I have inverse Laplace of 4 e raised power minus s pi by minus s pi by 2 divided by s square plus 16, s square plus 16. हमें इस चीज का फाइंड करना है. So now comparing this with this f of s e raised power minus as f of s, अगर मैं इस चीज के साथ इसको कंपेयर करूंगी, so यहाँ पे e raised power, forget about the 4, what is s is there, minus s is there, so what is a here? Here a is equal to simply pi by 2. A is pi by 2. Comparing these two, This is the simple means by finding the inverse transform. So A is pi, आपको खाली ये याद रखना है, that is the inverse Laplace transform e raised power minus as f of s is always given by f of t minus a u a of t. ये आपको याद रखना है बस. Then you can find out. So here A is this. Now what is f of s? अगर मैं f of s सबसे कहूँ, f of s is simply 1 divided by s square plus 16. S square plus 16. Not 1, we will write down the 4 here also. F of s is 4 divided by 16. So what, किसका ये इनवर्स ट्रांसफॉर्म है? अभी हमने इतने सारे जो लिखे हैं इनवर्स, दिस ना फोरियर ट्रांसफॉर्म हमने बहुत सारों का लिखा है अभी. This is s divided by 4. So this is omega divided by s square plus omega square. Omega divided by s square plus omega square. So किसका है ये? Sin of यहाँ पे
cos omega.
sorry हाँ, sin of omega t, साइन का, नॉट कॉस का. कॉस में फिर s डिवाइड बाय, तो यहाँ पे ओमेगा डिवाइड बाय ओमेगा स्क्वायर प्लस ओमेगा स्क्वायर. सो व्हाट इज f of t? सो किसका ये है? f of t इज sin of 4t. ओमेगा है ना, sin of 4t. So we find out f of s, f of t. You can use it in this particular formula and find out the value. So what will be the inverse Laplace transform of this 4 e raised power minus s pi by 2 divided by s square plus 16? What is it equal to? It is f of t minus a. f of t क्या है? Sin. So it is sin of 4 t minus pi by 2. a pi by 2 है ना, t minus pi by 2, and u of a and u pi by 2 of t, right? So you can further simplify it a bit. So you can write down this as sin of, now अगर इसमें 4t, sin of 4t minus 4, जब इसको मैं मल्टीप्लाई करूंगा, it will be 2 pi, then u pi by 2 of t. Now sin 2 pi minus theta, और माइनस अगर मैं इसको बाहर ले लूं, माइनस साइन 2 पाई माइनस थीटा, दैट इज साइन ऑफ थीटा. माइनस इंटू माइनस आपका वो प्लस हो जाएगा. सो इट विल बी इक्वल टू साइन ऑफ 4t प्लस साइन ऑफ 4t u pi by 2 of t, u pi by 2 of t. So this is actually the inverse Laplace transform. Now similarly, जो फर्स्ट में आपको थोड़ा सा कंफ्यूजन हुआ होगा, यहाँ पे आप इस चीज को आप इसी तरह से कंपेयर करिएगा यहाँ पे. सो f of s यहाँ पे आपका है 1 divided by s plus 2, a आपका 3 है यहाँ पे, and so this is the inverse Laplace transform of f of t. f of t is e to power minus 2t. So वही 2t मैं यहाँ पे यूज कर रहा हूँ, and I can find out the inverse Laplace transform. ठीक है? So that is one more. So we can just write down the inverse. अगर आपको Laplace transform हो रहा है, you can directly find out the inverse Laplace transform from that very case. Now this is okay. Now one more important thing which we will require, that the Laplace transform of t raised power n f of t. अभी तक हमने खाली Laplace transform of t raised power n किया था. Now if I have some function that is multiplied by t raised power n, its Laplace transform is always, इसको भी जरा बोल्ड में आप रखिएगा, its Laplace transform is always equal to -1 raised power n, then dn by dsn with respect to s, then f of s. ये हम बाद में, हमें इसकी जरूरत पड़ेगी, अभी नहीं, लेकिन इसको याद यहाँ पे रखना पड़ेगा. Okay, fine. So this is all about the Laplace transform as well as the inverse Laplace transform. Now, in the next lecture, we will be solving some the differential of a function using the Laplace transform. How we define the differential of a function using Laplace transforms. Okay. Now, if you have any question or any query, you can just ask the me. पूछो.
सर जो फर्स्ट मीटिंग थी ना सर, उसकी सेकंड स्लाइड अगर आप दिखाते एक बार फिर से, उसमें डाउट.
मैंने वो सेव नहीं की, बट आई विल जस्ट शेयर द लिंक। मैं लिंक शेयर करूंगा, आप उस पे देख लेना, ठीक है। मैंने स्क्रीन
ठीक है,
से शेयर ये ना सेव नहीं किया है, बट आई विल सेंड यू ए लिंक। मैं उसको अपलोड करूंगा अभी, एंड देन आई विल सेंड यू ए लिंक, ठीक।
ठीक है सर।
ओके, एनी अदर क्वेश्चन? कहाँ पे डाउट था बाय द वे? तुमने लिखा होगा ना इस पे, बता दो अभी। We have some minutes left in this meeting, so if you have
सर उसमें
or you just
ली थी ना।
hmm? If you have doubt, that is one thing, but if you have miss something, then you can tell me. अब अगर miss हुआ है, then that is not an issue. You can see it from the video I will send you. But if you have a doubt, then I will clear it. Missing and doubt is
सर इसमें लैपलास ट्रांसफॉर्म में आपने ली थी ना लिमिट 0 to infinity, और
yes,
उसमें फोरियर में लेते हैं -infinity to infinity।
very good, nice.
उसमें दिखाया आपने, उसमें उसमें दिखाया ना आपने, दिस लैपलास ट्रांसफॉर्म इज इक्वल टू फोरियर ट्रांसफॉर्मेशन, फोरियर ट्रांसफॉर्मेशन इनटू e⁻, कुछ दिखाया था सर उसमें।
Right.
उसमें लिमिट्स में डाउट है।
ओके, लिमिट्स में डाउट है, फाइन। नाउ सी, जब हम असल में वही चीज मैं आपसे कह रहा था कि दिस लैप्लास ट्रांसफॉर्म का जो एक्चुअली अराइज है, व्हाई वी आर एक्चुअली ट्रेकिंग इट, how does this Laplace transform actually, it actually arise from the power series. जब हम पावर सीरीज में लेते हैं, पावर सीरीज कैसे हम लेते हैं कोई भी फंक्शन का, लाइक वी हैव सम समेशन ओवर n a n x raised to power n, इस तरह से है, राइट। where you know that the n can take the values like 0 1 2 3, now it depends upon these coefficients, now it will always depend upon these coefficients. So we are taking here the values from 0 to infinity, 0 to infinity, forget about the this Fourier transform। फिलहाल मैं कह रहा हूँ इसका ये कहाँ से अराइज होता है। So now you know that, but we are taking this sum is called as a discrete sum, but when we are taking the all the values, for example the values between 0 and it becomes a continuous, then in this, like for example we can take these constants, we can take, I can take it 1, if it is 1 then what it will become, this will become like x raised power 1, x raised power 2, x raised power 3, x raised power 4, so on up to x raised power n, and that I can put as like 1 divided by 1 minus x. Similarly, if this is what, if this a n जो coefficients है आपका n factorial है, if they are, it is the n factorial, then we have the exponential, we will get an exponential function like this. Similarly, now for example, now again if there are some other values, then this and we are taking the, for a continuous function we are taking the values that are going from, that are taking the in between values like 0 to 1, 0 to 3. So in that case this discrete sum actually becomes some 0 to infinity e raised to power some f of t, then the exponential जो x raised power t है या x raised power n है, it becomes an exponential. There is actually इसकी थोड़ी सी लंबी अंडरस्टैंडिंग, मैं शॉर्ट में इसको बता रहा हूँ, f of t e raised power minus st, where s you know that it can take the complex values e to power dt. So that is why we are taking it from the 0 to infinity. The 0 to infinity actually comes from this particular, so it is actually a summation of a power series, right? So but well, now that is one of that, as I said earlier, there are so many things we can explain this the Fourier transform. This is one example where, this is one case where we can say that how does this how, so this actually this Laplace transform equation, but you know that अगर अभी मैं आपको अभी इससे पहले आपको बता देता, आपको पता नहीं, if I write down this equation 0 to infinity e raised to power minus st f of t into dt, अब आप क्लियरली बताओगे यो दिस इज a Laplace transform equation, but where does it come from? It actually comes from this power series. So but in power series we are taking the discrete component, but if we have a waveform, like we do not have a discrete, we have the continuous step, so we are taking it over the integral from 0 to infinity, right? So you can say that this Laplace transform is actually the limiting case of a Fourier transform. While in Fourier transform what I did, we are taking the negative frequencies also, we are taking the negative frequency, but for this Laplace transform we are taking it only the positive. What are the, for example the area under the curve, so we are taking it only from 0 to infinity. because see, because as the exponential term is there, we cannot have the exponentials on the both the sides. Either it will be exponentially like this or exponentially like this. So that's why we are taking it in the form. So we are actually taking the propagation of a wave. अगर आप graphical से, so मैंने इसी वजह से वो example है. So we are actually taking it from the 0 to infinity. That is the reason we are taking it from 0 to infinity rather than taking it from minus infinity to like we did in the Fourier transform. हालांकि फोरियर ट्रांसफॉर्म का भी एक केस है, फोरियर ट्रांसफॉर्म में भी हम 0 to infinity भी लेते हैं, दैट इज आल्सो द one of the case. But taking the negative frequency into the consideration, we can also take it from minus infinity to infinity. But Fourier transform में भी हम 0 to infinity ले सकते हैं, like we have seen the finite sine and cosine transform, हमने उसमें भी 0 to infinity लिया है ना. So try to understand. So for example, if I have some wave, जैसे मैंने आपसे कहा था कि for example, a mass attached to a spring, so we have the exponentials as well as the sinusoids present. So there is actually a propagation sinusoids as well as it will go on a decrease. So there is a damping in that. So it will just stop at a certain point. Is it okay?
जी सर.
So that's
सर, और
actually
जो ये लिया ना आपने लिया ना ये स्प्रिंग मास सिस्टम, मतलब
हाँ
जिसमें इनिशियली
हाँ
वैक्यूम में रखते
हाँ
हैं और
हम्म
इसमें साइनोसाइडल वो
हम्म
वेव बनती है सर,
हम्म
जो लेते हैं. लेकिन
हम्म
इसमें जो ग्राफ दिखाया आपने वो ओरिजिन से नहीं लिया सर. साइनोसाइडल अगर है तो वो ओरिजिन से होना चाहिए ना सर.
अरे साइनोसाइडल नहीं, मैं आई मीन टू से द साइनोसाइड. साइनोसाइड्स में आपका कोसाइन भी आता है, साइन भी आता है. we sines as well as the cosines, we call them as sines. Either you can take it like this or you can, अगर cos है तो you can take it like this. It is not
यस सर.
an issue. समझ रहे हो बात को?
जी
साइनोसाइडल से मतलब
जी
नहीं है साइनोस, इसीलिए मैंने साइनोसाइड्स कहा था. these are called as a sinusoids, चाहे वो किसी भी तरह हो, ये है कि कहीं तो ऐसे था. We call them as a sinusoids,
जी सर.
right?
जी
So it could be a cosine
ओके.
as well as a sine. That's not an issue.
ओके.
Anything else? ठीक है.
जी सर, वो एक्सपोनेंशियली डीके दिखाया था ना सर, वो ग्राफ कैसे पिक्चर में आता है?
क्या चीज?
जो आपने दिखाया ना सेकंड केस इसमें,
अच्छा,
मतलब ग्राफ जो एक्सपोनेंशियली डीके
जल्दी
होता
से
है.
सुनो, बिकॉज इट इज गोइंग टू डिस्कनेक्ट. एक्सपोनेंशियल डीके कैसे? मैंने कहा था फॉर एग्जांपल एक मास है किसी अटैच्ड स्प्रिंग में. सो फॉर एग्जांपल इफ देयर इज नो एयर रेजिस्टेंस, आई जस्ट प्लग इट विल, देयर विल बी अ साइनोसाइड. बट इफ देयर इज सम रेजिस्टेंस प्रेजेंट इन दिस एंड आई प्लग दिस मास, यानी ये पास को मैं खींच रहा हूँ, तो इसमें क्या होगा? एक तो आपको जो मैंने ये एक्सपोनेंशियली डीके कहा था, एक्सपोनेंशियल डीके इन द सेंस कि for example, at what time, what was the amplitude of these oscillations, at what time this amplitude, the amplitude goes on decreasing. So that means, so if I plug this mass in the first case, mass चाहे मैं कितना भी इसको pull करूं, there is no resistance, the amplitude will remain the constant. इस तरह से. The second case में मैंने क्या कहा था? For example, अब it will exponentially decrease. This is actually the amplitude of the oscillations that are there. For example, if the mass is present like this, then there are pure there is no oscillations, but there are pure, it will go on decreasing continuously, right? It will go. So that is an exponential decay. In the third case, जब मैंने कहा था कि it will be like कि मतलब ये back and forth आपका हो जाएगा, ये spring जो है back and forth. I cannot show it here. It is actually a picture. So it will go back and forth, slow down. So there will be a like this. So there,